This video is going to reteach the first part of Chapter 10. It goes quickly, so pause and process and practice as much as you need to. The first thing you need to understand to get through this chapter is the concept of what a mole is. A mole is simply a unit that means 6.02 times 10 to the 23rd pieces, or particles. A particle could be an atom, if we're talking about a single element. It could be a molecule, or a formula unit, if we're talking about a compound. Or it could be an ion, if we're talking about something with a charge. These words, atom, molecule, ion, and formula unit, although I won't usually use that, are trigger words that mean you're likely going to have to use Avogadro's number, which is that 6.02 times 10 to the 23rd number. That literally means the number of particles in 1 mole, the same way that when you hear the word dozen, you immediately think 12. 12 is the number of particles in a dozen. 6.02 times 10 to the 23rd is the number of particles in 1 mole. The next term you need to be familiar with is molar mass. Molar mass comes from the periodic table. For an element like neon, it's pretty straightforward. You simply go to the periodic table, find that element, and the number at the bottom. So for neon, 20.179 or 20.18 is the molar mass. The unit for every molar mass is grams per 1 mole, or just grams per mole. For a compound like carbon dioxide, we need to find the elements that make it up, carbon and oxygen. Carbon's molar mass is 12. We have 2 oxygens. So 2 times 16 gives us 44 grams per mole. Aluminum nitrate is more complicated. In aluminum nitrate, we have 1 aluminum. We have 3 nitrogens, because that 3, which is touching the parentheses, applies to the N, which is in parentheses. That 3 outside the parentheses also applies to the O, which is inside the parentheses. Since there are already 3 O's, and we have 3 O3s, we have a total of 9 oxygens. So when we go to find the molar mass, we need 1 aluminum, 27. We need 3 nitrogens, which are each 14. And we need 9 oxygens, which are each 16, which gives us a total molar mass of 213 grams per mole. Once you have those terms straight, you're ready to go in and start some of the easier problems. For these first 2 questions, how many atoms are in 1 mole of carbon, or how many molecules are in 1 mole of CO2? Because we're talking about 1 mole, the answer is simply Avogadro's number. There's 6.02 times 10 to the 23rd atoms in a mole of carbon. Atoms because carbon is a single element. There are also 6.02 times 10 to the 23rd molecules in a mole of CO2, molecules because CO2 is a compound, a combination of different elements. When we have a problem like this one, how many atoms of carbon are in 4.3 moles, we have to do a calculation. We can't do that in our head. So we always start with the number written in the problem, which happens to be 4.3 moles of carbon. We're going to multiply that by a conversion fraction. We know that moles of carbon needs to be canceled out, so that's going to go on the bottom. We're trying to get atoms. You know that the definition of 1 mole is 6.02 times 10 to the 23rd. So therefore, when we calculate 4.3 times 6.02 times 10 to the 23rd divided by 1, we get 2.59 times 10 to the 24th atoms. The next problem is very similar. We're just sort of going backwards from what we did in the previous problem. We're starting with this, 2.6 times 10 to the 26th molecules of CO2. We have to have molecules of CO2 on the bottom. We're trying to get to moles. We know that 1 mole is equal to 6.02 times 10 to the 23rd. When we do the math out, being careful to use the E button, we get 432 moles. Be careful not to abbreviate the word molecule. You do not want to confuse molecule with mole. Write the whole word molecule out. For the last part of this tutorial, we're going to be converting between moles and grams in a compound and between atoms and moles in a compound. First problem, how many grams in 0.55 moles of CO2? To go between grams and moles, we always need to use the molar mass. We know moles of CO2 must go on the bottom to cancel. We previously figured out that the molar mass of CO2, 1 carbon, which weighs 12 grams per mole, and 2 oxygens, which is 16, has a total of 44 grams per mole. When we calculate that out, 0.55 times 44, we get 24.2 grams of CO2 in 0.55 moles. For the last problem, how many oxygen atoms? That's a trigger word. You should be seeing that word and going, wow, I think I have to use Avogadro's number. We're going to start with 0.55 moles of CO2. The only thing you need to understand right now is that you have to get rid of moles of CO2 by putting it on the bottom. Then you need to think, what do I know about a mole of CO2? You know the definition of a mole of CO2 is 6.02 times 10 to the 23rd. What is the unit though? We're talking about CO2. Is that an atom or is that a molecule? Well, it's made up of carbon and oxygen, 2 different elements, so it has to be a molecule. So it means we're not done. We'll be done when we have oxygen atoms in the top of our fraction. We have to have molecule on the bottom to cancel out. Our moles were canceled previously. Look at CO2. If that's 1 molecule, how many oxygen atoms are in 1 CO2? Well, there's 1 carbon, but that O2 tells you there's 2 oxygen atoms. Now we're done. 0.55 times 6.02 times 10 to the 23rd times 2, and we get a pretty big number, 6.6 times 10 to the 23rd oxygen atoms. At this point, you should be able to do a number of the problems in your review packet. If you can't, go back, watch the video again, pause, and practice whenever you need to.